Our high school holds a math tournament every year for middle school and high school kids. It's pretty amazing having over 1,500 kids come on a Saturday, compete, and maybe earn a trophy for their effort. But it's also a lot of work. We're at the point of the year where we start writing new problems for next year's tournament. We have math first thing in the morning, so food is kinda always on our minds. One morning we start feeling like having some toast. Toast is awesome. You can put so many toppings on it: strawberry preserves, peanut butter, grape jelly, fruit butter, and math inspiration strikes again. Toast could be turned into a golden rectangle. First, measure the short side, our toast is about 3 inches, and make a square with sides of 3 inches. Then, we draw a line from the midpoint of one side of the square to the opposite corner. Extend that length, about 3.35 inches, from the midpoint, draw a perpendicular line, and voila! You got a golden rectangle toast. We have side lengths of 4.85 inches and 3 inches. Their ratio is 1.61. Now, you can repeat the process again, this time with a smaller square. Measure the side length, create a new, smaller square, measure the length from the midpoint to the opposite corner, extend that length, and repeat all over again. As long as you do this, the ratio of the longer side to the shorter side of the rectangles will always be 1.61, or the golden ratio. For any golden rectangle toast with side x, side y, and long side x plus y, the ratio of the long side over side x equals the ratio of x to y equals 1.61, the golden ratio. Anyways, you can also draw a golden spiral, a logarithmic spiral, which is all over nature. Pretty cool. Now, since we're such dedicated math nerds, students, we have math team instead of a lunch period. The oven goes off and what is it? It's pizza! It's slightly cheesy, but now we have to find a way to make the most number of pieces out of the least number of cuts. For this case, it doesn't matter if each person gets the same amount of pizza, but rather each person just has to have a piece. Sometimes life's not fair. So here's our pizza. If we cut the pizza once, we make 2 pieces. If we cut the pizza again, we can make at the most 4 pieces. If we cut the pizza a total of 3 times, we can make 7 pieces max. Keep in mind, our slices don't have to be the same size. We just want to find the maximum number of cuts possible. If we cut the pizza a total of 4 times, we can make a maximum of 11 pieces. Let's look at our results. Now, this is kind of interesting. The maximum number of pieces we can get are close to triangular numbers. Really quickly, triangular numbers are basically the number of dots that can form an equilateral triangle of various lengths. The first triangular number is 1, the second triangular number is 3, the third is 6, and so on. Triangular numbers follow the formula quantity n times n plus 1 all over 2, where n is the nth triangular number. So back to the chart. Notice that the maximum number of pieces we can make with n cuts is 1 more than the nth triangular number. So, we can say that pizza cutting, pancake cutting, waffle cutting, whatever cutting, formula is quantity n times n plus 1 all over 2 plus 1. But hey, what about dessert? The festive but humble donut. But what is a donut without a delicious creamy filling? If we were to stuff as much filling into the donut as possible, and I'm talking to within an inch of the donut's life, how much filling do we need? We need to find its volume. Fortunately, a donut is shaped like a torus, which is basically a solid generated by revolving a circle in space around an axis in the middle. To find the volume of our torus/donut, we need one simple formula. Volume equals 2 pi squared times big R times little r squared. We can find these radii by cutting the donut in half through the middle. From there, you can easily measure the radii with a ruler. For this donut, lowercase r is 0.5 inches, while uppercase R is 1 inch. Now, plug these numbers into the formula and solve. The volume of the donut is therefore about 4.9 cubic inches. That means 4.9 cubic inches of delicious, sugary filling. So in less than 4 minutes, we've gotten 3 math problems written and a meal. Mathelicious!